Let's look at Netscout Visibility without borders in action with a demonstration of NGeniusONE in a hybrid AWS and on-prem deployment. The demonstration will consist of a number of sections. A description of the demonstration architecture, a hybrid deployment in both on-prem and in the cloud, AWS in this case. Then NGeniusONE in action, a demonstration showing workflows to help optimize and triage service and application issues. And finally, visibility in the multi-cloud deployments, extending the demonstration to include Azure, Oracle Cloud, and GCP. Our demonstration architecture encompasses virtual machines in vCenter and VMware NSX-T in the data center, and workloads instances in AWS running a containerized application, interconnected over Direct Connect and VPN. The resources are accessed by the users wherever they are, over the internet, or of course through the WAN or SD-WAN architectures, and the resultant applications are with workloads in AWS connecting back to the on-prem resources. Netscout Smart Data and NGeniusONE provide the needed visibility across this hybrid architecture to deliver advanced application troubleshooting. Smart data is generated by Netscout patented technology called Adaptive Service Intelligence, or ASI for short, inside physical InfiniStream ISNG appliances and virtual cloud-friendly vStream software. It provides meaningful key performance metrics out of packet data and stores indexes of sessions and packets for packet forensics after the KPIs have done their job pinpointing the issue. Smart data understands the relationships of one component to another, user to application to microservice to database, and builds or discovers the services in the chain. If there is a performance issue, Smart data sees the database, the web server, the app, the microservice, the shared service or enabler. That's the root cause. Smart data is also used to optimize application performance, say seeing the difference of the performance with a cloud-hosted database versus one on-prem, or a co-located web-based server versus one in EC2. Compute resources in the data center are monitored by ISNG and vStream, which receive the packets from spans or taps, aggregation switches, and service insertion technologies in the case of VMware NSX-T. Smart data is forwarded to the NGeniusONE Global Manager on-prem for performance and service assurance workflows to troubleshoot what's going on. AWS EC2 instances and the microservices app are also being monitored by vStream hosted in AWS VPCs, where traffic is sent from the EC2 instances ENI to the vStream using VPC traffic mirroring. Of course, we can leverage other AWS architectural components such as the Gateway Load Balancer to gain access to the packets more efficiently behind fleets of appliances like firewalls or IDSs. Our AWS vStreams report back to its local manager, also hosted in AWS, which in turn reports to the NGeniusONE Global Manager on-prem to provide the single pane of glass for the service assurance insights we need, no matter where the workloads are deployed. This is Netscout Visibility without borders. NGeniusONE's service dependency helps you visualize how these applications are communicating across the different borders, on-prem and in AWS. What's special about this is each of the connections represents the actual communication and performance metrics of the server-to-server communication, and it does it per application. So we can use this to investigate what's going on and understand performance bottlenecks. To illustrate, as we expand the view, we see an app server now migrated to EC2, but it's talking to two Oracle database servers, one on-prem and one in the cloud. By examining the connection between these servers, you see the average responsiveness of the app to the database server, and naturally, the access to the one in EC2 is far faster at 2 milliseconds versus 117 milliseconds for the on-prem Oracle server. This can be used to prove the success of the migration of the app and database servers together. NGeniusONE has workflows to help for service triage and performance analysis day zero onwards, and has a consistent top-down methodology to see what's going on, from dashboards to service monitors to sessions to packets. The NGeniusONE Hybrid Cloud Dashboard, a view of common situational awareness for global or hybrid view of all the services from which we drew the service dependency earlier, a DevOps application view, and then infrastructure views of AWS, Colo for the Direct Connect and the data center domains, and finally a NetOps view for network analysis across the environment. The DevOps view looks into the tiers or microservices app, wherever they reside, the front end, the app layer, the database layers, Active Directory, DNS, and so on, each an essential part of the overall working app and critical to the performance. We can drill down into each layer to examine the specific performance. Looking at Oracle, we see 31% slow responsiveness, probably due to the cross-domain database access we saw earlier. And yes, drilling into the database monitor, we see the top row to the Oracle server in EC2 running at 2 milliseconds average responsiveness, and to the on-prem database at 117 milliseconds, a big difference in performance. Looking at the performance over time for the database, we see success failure rate of the transactions over time, response distribution, and error code distribution and throughput. By examining the errors, we observed 942 table view does not exist, and we can drill down into these sessions and see what's going on, which reveals access to the corporate Oracle database, and the table view does not exist error. If we want, we can go to the packets and see what's going on. Here's the error, table view does not exist, and the request, the specific Oracle table components spelled incorrectly in this case. Vital information to Devops and even the DBA. IngeniusONE Smart Data provides the evidence of the application making the call and even the failing transaction in this case. Back to the dashboard, we see the performance of the layers of the application over time, each row representing a tier of the app: front-end, app, Oracle, MySQL, Active Directory, and each column representing performance metrics: average app response time, network connect time, successful failed transactions, and error codes. We can home in on the application layer. It's reporting slow application response time but very quick network time, so application deployment architecture is okay, but it's the performance of the application workloads themselves that is a question. Through looking at the failure rate of the application, 500, 501, 503 server availability issues. We can drill down to this detail, this time to the Web Services Monitor, showing the details of the application layer for this EC2 server. Latency distributions over time with latency consistently around 300 milliseconds. Performance variation with latency, showing fast, degraded and slow times, and error code distribution showing the errors of the application. And of course we can see the details as before, the sessions and the packets. The sessions reveal the session type, the URL, order history 2.php, that's a GET, and 503 service unavailable error. And of course we have access to the packets if necessary. I've shown you IngeniusONE service triage and optimization in action, with drill down from dashboard to service monitors to the sessions. But IngeniusONE had already done the work for us and presented alerts on the first dashboard, displaying warning and critical alerts for the application and Oracle tiles. Drilling down into the notification center reveals what's going on. For Oracle, errors and response time consistently over the threshold of 60 milliseconds for that period of time. And for the application server, a similar story. The alert metric over time showing response time very high and consistently over threshold. Of course, we have baseline deviation events as well as machine learned events or cause and effect. From these problem notifications, you can continue to use the IngeniusONE workflows to examine the issues in detail. We extended our demonstration by deploying workloads into Azure, GCP, and OCI, additional borders beyond on-prem NSX and AWS. vStream operates the same in these environments. Just like in AWS, NG1 and vStream is deployed through the respective platforms' marketplace offerings. Packet acquisition is handled differently in each environment. For example, like AWS, GCP has packet mirroring capability. For the others, Azure and OCI, we can leverage vStream's lightweight technology which deploys inside the workloads and containers and pods to acquire packets and generate smart data for multi-cloud deployments. Our service dashboard can now be divided into each cloud and on-prem domains and leverage all the same workflows of IngeniusONE no matter where your workloads reside. Service dependency discovery extends its view across all the clouds, as you can imagine, with interconnectivity shown to help optimize the traffic, performance, and also cost, as traffic now goes from one domain to the next and the next. And finally, talking about volume and costs, Traffic Monitor, this time instrumented at the edge of the cloud and on-prem, showing you the applications and traffic volumes that traverse your clouds and access the resources in your on-prem data center. In summary, Netscout Smart Data and NGeniusONE provides the needed visibility across hybrid and multi-cloud deployments to deliver advanced application troubleshooting, workflows to help triage issues and optimize performance in these complex, interconnected environments.